All right, let's start a new unit. Let's learn how to graph. And we're going to graph lines, and we're going to graph lots of lines. So we're going to be able to graph linear equations on the coordinate plane, and that's going to be our main focus in this unit. So you'll get really good at graphing. So let's get started by taking a look at what is the coordinate plane and how do we graph on it, how do we connect that, mostly from the table. And then we'll look at different ways that we can graph. So why a coordinate plane? Well, because your world is a coordinate plane. You've heard of lines of latitude and longitude, hopefully, in geography class. Well, here's the connection to math. Lines of latitude and longitude, the equator, the prime meridian, those are your axes, your x-axis and y-axis. And from that, we get coordinates. I know this isn't the true equator and prime meridian, but just play along. So let's say we've got 35 degrees east and 52 degrees north. And we've got a specific location to send your signal or to send for help if you get lost. So we can track that down from satellites to get us an exact location. For instance, let's say this is our prime meridian and the equator. We could say, well, Lake Kalundinskoye is at 80 east and 53 north, so that would be in Asia. Whereas Lake St. Clair, negative 83, so that would be roughly 83 west, 43 north. That's going to put us in North America. So exact locations based off of the idea of the coordinate plane. So here's what the coordinate plane is. We've got different parts of it, and when we start talking about those different parts, you're going to want to write those down. So starting off here, we call this the origin. Okay, it's called the origin because it's where we originate everything from. It's your starting point. Start here when you start graphing. This is our x-axis, and this is our y-axis. Okay, the x-axis goes horizontally, the y-axis goes vertically. It's where we start all of our discussions from this origin. So when we get an ordered pair, that's an x-coordinate, which tells us how far we are along the x-axis. Then we also have a y-coordinate, which tells us where we are on the y-axis. And those two combined narrow down our specific location. So if this is our exact coordinate here, if I'm starting at the origin, I go left 1, 2, 3, 4, 5 units. And then I go up 3 units. So our coordinate for the ordered pair would be -5, 3. It gives us an exact location, and that's the benefit of that. So once we talk about that, also the other thing that we talk about are quadrants. For example, this is the first quadrant. Notice we divide into 4 sections. Everything above the x-axis to the right of the y-axis is quadrant 1. We call this one quadrant 2, quadrant 3, and quadrant 4. And hopefully you notice some things about the coordinates there. Well, to get to the first quadrant, well, I'm going right always, so that's going to be a positive x. And my y, I'm above the x-axis, so I've got to have a positive y coordinate. Here, can you guess what I have to have? I go negative and then positive. And all the coordinates in this quadrant will have negatives for their x and positives for their y. For 3, left and down, so negative, negative are going to be my generalized coordinates. And everything in the fourth quadrant will be positive for my x and negative for my y. Okay, so those are the basics of the coordinate plane. We'll use that, and you got to know how to use the coordinate plane if you're going to be graphing. So let's move along and identify different points. So pause the video and identify what are the ordered pairs for A, B, and C, and then plot points A, B, and C on this coordinate plane down here. Start it when you're ready. Okay, so here are the coordinates and the ordered pairs for A, B, and C. Check those, compare with what you have. Notice we always put the parentheses around them separated by a comma. That's just a general way of writing that. When we plot the points in the coordinate plane, if we're looking at A, remember that would be in quadrant 2. B, that would be in quadrant 4. Yes, we use the Roman numerals. And then c is in neither 3 nor 4. It's right on the y-axis, right on the dividing line. Okay. Let's talk about solutions, what that means to be a solution of an equation. So if we have this equation here, 2x plus 4y equals 8, a solution would be the ordered pair that produces a true statement. So the specific value of x and y is going to make this true. So for instance, let's take a look at negative 1, 4. Is that a solution? Well, 2 times negative 1 is negative 2, and 4 times 4 is 16. Negative 2 plus 16 is 14. 14 does not equal 8. Therefore, negative 1, 4 is not a solution. 2, 1. Well, if we plug 2, 1 in, 2 times 2 is 4. 4 times 1 is 4, and 4 plus 4 is 8. So since that comes up with a valid solution, we'd say yes, that is a true statement. The values of x and y that go into the equation make this a true statement. And once we find all of these solutions, we plot those on a graph. And a graph of an equation is the set of all points that represents every single solution. So if we were to take a look at negative 1, 4, it points way up here. It's not on the line. That's also why it's not a solution. 2, 1 is a solution. Okay, and you can quickly and easily see that 4, 0 would be a solution. 0, 2 would be a solution. And that's the benefit of having the graph. We can find all the solutions very quickly. Okay, so how do we take a function and convert it to a graph? Well, here's the function rule, the equation, and we're going to start with our domain of negative 2, negative 1, 0, 1, and 2, and then we want to graph that function. So in order to do that, we just take those values, and what we're going to do is we're just going to substitute those into the equation. So I'll start with negative 2, let's have negative 1 as our 0, 1, and 2. So when we substitute those values in, so 2 times negative 2 is negative 4, minus 3 is negative 7. And as we continue substituting our values of x into the equation, we see 2 times negative 1 is negative 2, minus 3 is negative 5. 2 times 0 is 0, minus 3 is negative 3. 2 times 1 is 2, minus 3 is negative 1. And 2 times 2, 4, minus 3 is 1. So once we get those points plotted, we've got our set of ordered pairs. So negative 2, negative 7. And we can plot those points, and there's our graph. Those are all 5 points that fit the equation with the given domain. The range of these points, as you can see, we know the range of the y-coordinates. The range would be these values. So we could say, well, the range is negative 7, negative 5, negative 3, negative 1, and 1. Okay? Now, when the equation is solved for y, that makes it pretty easy to create a table and convert that to a graph. When it's in this form, we call that standard form. Standard form is when we have the x term and the y term on the same side of the equation and the constant term on the other side of the equation. When it's in that form, it's maybe not quite as simple to get it ready to solve. So we want to solve the equation for y, because when we do that, all we have to do is insert our x variable, our input, and it'll give us our output. So let's solve for y first of all. So remember, we would subtract 3x from both sides, and then we've got 2y equal to 8 minus 3x, and then we would divide by 2 on both sides of the equation. That would give us y equals 8 divided by 2 is 4, minus 3x over 2, or 3/2 x. So that would be our equation. I'm just going to move it over here. So now if that's our equation, we need to make a table. The easiest way to make a graph, if you don't know any of the ways to get started, is just always create a table. And typically it doesn't matter what your values are, but we can go and let's choose different values. We want to try maybe some negatives. They don't always have to be in order. So then 0 is always a good one to try, and then maybe a couple positive numbers. Okay, so once we do that, all we have to do is then evaluate these x values for the given equation. So we just evaluate. Okay, so if I want to now graph the equation, I mentioned we need to evaluate the values of x. So I can take x as -3, so 4 minus 3 halves. And we evaluate that times -3. And we get a value of 8.5. I can enter that into my table. Now we do the same thing with -1. 3 halves times -1. And we get 5.5. Whoops. 0, well, 4 minus 3 halves times 0, that's going to give us 4. And then 4 minus 3 halves times 1, well, 4 minus 3 halves is going to be 2.5. And then 4 minus 3 halves times 5 gives us a value of -3.5. So once I get those points into my table and plot it onto my graph, what I can do is then show all of the solutions by connecting them with a line. So if I get out my line tool here, I can connect the dots and show what every solution would be. So those are steps for graphing an equation. Let's say we have a special equation such as y equals 4. And that equation, if I were to create a table, notice there's no x value. So if I start creating my table, I know, well, x has no effect on y. So no matter what I choose for x, y will be 4 because there's no effect of x. So if I start graphing those, 0, 4, 1, 4, 2, 4, 3, 4, I see the pattern. It's going to be a horizontal line through the y-axis at 4, because regardless of the x value, y is always 4. So we see this is a horizontal line, 4 units above the x-axis. Or another way to think of it is it goes through the y-axis at 4 because y is always 4. Okay, the other special type of line would be x equals -3. So same thing, x equals -3. So regardless of what y is, x will always be -3. And we could have multiple different values. But x is always -3, y can be anything. Okay, so the graph of x equals -3, I plot my points here, 3, -7, and we see that it is a vertical line. Not a very straight one that I drew, but I should use a ruler next time. So the graph of x equals -3 is a vertical line, and it's 3 units. This one's to the left of the y-axis. And another way to remember it is it cuts through the x-axis at -3. And so those are two special graphs that you'll get to learn how to do. The other thing we want to do is graph a function with a limited domain. So here's our function y equals -half x minus 1. Its domain is x greater or equal to 0. So the only values that we can have there have to be greater than 0. So I'm not going to choose any negatives this time. So I can use 0, 1, I could jump down to 2. I could maybe even do 5 or 10. Okay, so once we have that, we just evaluate that. So 0 times a half is 0, minus 1 is negative 1. Half of 1 is half, minus 1 is negative half. Half times 2 is 1, minus 1 is 0. Half of 5 is 2.5, minus 1 is 1.5. And half of 10 is 5, minus 1 is 4. Okay, once we have those points plotted, that's how it looks like on our graph. We'll connect our points. Now, we haven't learned our geometry yet, but you're going to connect it with an array, okay, because it's a limited domain. It's starting at this point. That's the smallest it could be. And it continues through there because x is greater or equal to 0. Okay, it's anything greater than 0. So the range now, let's use an inequality to identify that. Our range, what can our range be? Well, what values of y can we have? Well, the smallest one we have is that negative 1. And everything else is above that. So we'd say our y value is greater or equal to negative 1. Be every possible range value. All right, so that's all that we're going to do today. We learned how to graph a function. Remember, you can always graph a function by starting with a table. Get your ordered pairs from the table by substituting those values in, plot those points, and you can, if it's showing all solutions, you can connect those with a line. If it's a limited domain, you can use array to show that. All right, have fun doing the practice work, and if you have questions, as always, I'll help you out in class.